Hello everyone, welcome to Algebra 1 with Miss Betsy. Today we are going to be talking about properties of equality, which is something that we'll be using continually from now through the rest of your math career, because it's these properties of equality that allow us to solve an equation for an unknown quantity that we have represented by the variable. Today we're going to be in section 3.8. My text is Algebra 1 for Christian Schools. It's the second edition, published by Bob Jones University Press, and I'm going to be on page 115 if you're using the same text that I am. Just be aware that the third edition is not compatible with the second edition. So let's go ahead and pray, then I've got a lame joke, and we'll see what our lesson holds for us today. Father, I thank you for a beautiful day that you have given to us here in the middle of October. Father, I thank you for clear skies and for a cool breeze. And I thank you for the continued evidence of you making all things new and of the changing of the seasons. Father, I ask that you would help us to pay attention and learn the things that we need to learn about using properties of equality to solve algebraic equations, and help us to be careful to honor you in all that we do. And I pray in the name of Jesus, amen. Okay, our joke for today, this one truly is bad, even for me. What do chickens and bands have in common? Well, they both have drumsticks. So, properties of equality. Now, what exactly does equality mean? Just a very simple, and I think this would be called almost a circular definition, but equality means the condition of being equal. If we have something equal, that means that the two different quantities have the same value. Okay, all men are equal in God's eyes. Men are not equal in each other's eyes. We compare and contrast and play favorites like crazy. But all men are equal in God's eyes, and we use properties of equality constantly in algebra, and we have what they call mathematical equalities. And this, I've already alluded to these a lot by my reference of a seesaw or a balanced scale with representing this equal sign here in the middle. When that scale is balanced, or when that seesaw is level, you have the same value, the same weight, or the quantities on either side of that seesaw have the same weight, so we say that those are equal. And this is what we're going to be working with a lot as we solve algebraic equations. And an equation, and we've talked about algebraic expressions and algebraic equations, and this is something that you guys were learning how to do when you were translating from English into algebra, and we started with something as simple as this: the sum of 9 and 5. And your instructions were to say, translate this English phrase into an algebraic phrase, or into a mathematical phrase. It's just a mathematical phrase because we don't have any variables in there, we just have numbers. What is the sum of 9 and 5? Well, sum is addition, so we would say that the way to translate this English phrase into a mathematical expression is to just say, we know that sum is addition, so this would be 9 plus 5. Now, what a lot of you wanted to do constantly, and some of your moms even would say to do this, is no, it's not 9 plus 5, it's 9 plus 5 is equal to 14. And while, of course, it's true, 9 plus 5 is 14, this is not what we were talking about in this type of a problem, because we're learning how to translate English words into mathematical symbols. And there's nothing up here that says equals 14, is there? All it says is the sum of 9 and 5. And that's what we call a numerical expression. It's a numerical expression because there are no unknowns in there. Now, if this had been the sum of a number and 5, instead of having 9, we had said a number, then that would look like n plus 5. We don't know what that number is, but we know that we're going to add 5 to it. And this would then be an algebraic expression because we have a variable included as a part of the expression that we're trying to write. But what we're going to be talking about when we have mathematical equalities, there's equals in there. And we now, if we were to change this problem here a little bit and make it say the sum of 9 and 5, I only have, I guess I've got a blue marker, that'll be better. The sum of 9 and 5 is 14. Now we have gone from a numerical expression, which was just 9 and 5, to an algebraic expression, which was a number plus 5, to an algebraic equation. And an algebraic equation is going to look like this. The sum of, this has to be a number. The sum of a number and 5 is 14. When you have is equal to, equals, that gets translated as, in the symbols of math, as an equal sign. So what we have now here is we have an algebraic equality. We're saying that what we have on the left-hand side of the equation, n plus 5, has the same value as what we have on the right-hand side of the equation. So our scale, or our balance beam, would be level, because n plus 5 has the same value of 14. And that's what we're talking about when we have equations. An equation is a mathematical sentence, let's see how they say it, stating that two expressions are equal. An equation has this equal sign here in the middle, and it says what you've got on the right-hand side of the equation, on the right-hand side of that equal sign, is exactly the same value as what you have on the left-hand side of that equal sign. And you're going to find out that equations can be either true or false. First, we're going to look at a couple of mathematical equations, and then we're going to look at algebraic equations and see what exactly it is that I'm talking about. So let's put two examples up here from our book. We're going to say 3 squared minus 5 times 7 is equal to negative 2 times 13. And then we have a second example that we are going to look at. And this says that 4 times 5 is equal to 3 plus 2 times 4. So, these are not algebraic equations, but they're just mathematical equations. They have an equal sign in both of them, but they have no variables. And that equal sign tells us that what we have on the left-hand side has the same value as what we have on the right-hand side of that equal sign. Well, how do we know if that's true? Well, you simplify. See what we end up with. 3 squared is equal to 9. minus 5 times 7 is 35. Is 9 minus 35 equal to a negative 26? How do we subtract signed numbers? 35 minus 9 is 26, and we keep the sign of that 35. So we have negative 26 is equal to negative 26, and we would say then that this is a true equation because we have the same, our minds can't necessarily wrap themselves around something that looks like this, but when we simplify it to a single number, it's very obvious to us, isn't it, that both the left-hand side and the right-hand side of this equation have the same value. Such a true equation. Now let's see what we have up here. And this might be something where somebody's misusing like the distributive property perhaps, or the associative property. I'm not exactly quite sure what they would be doing. But see, we have a 4, a factor of 4 on both sides of the equation, and a factor of 5. So they split 3 plus 2 up into 5. Let's see if this is true. You already can tell that it's not. 4 times 5 is 20. Does that have the same value as 3 plus 8? Well, no. 20 obviously does not equal 11, and that's what that slash through the equal sign is. It means it's not equal to. So when the two sides of an equation are not the same, we say that that is a false equation. We're going to spend this section looking at a lot of equations and seeing if they're true or seeing if they're false. First equation is true, the second equation is false. Now, so these were mathematical equations because there were not any variables in them. We're going to do algebraic equations now, which by definition are going to have to contain a variable. So, here's an example of an algebraic equation. We're saying that this expression over here, x plus 4, has the same value as 7. Well, what is going to be the value of x plus 4? Well, that's going to depend on what value we assign for x. So, we have two examples here. If we say that x is equal to 3, then we have 3 plus 4, is that equal to 7? And yes, of course, 7 is equal to 7. So we have come up with a value here, we've come up here that with a true statement if we have x be equal to 4. But what are we going to see over here? What happens if x is equal to 2? Then we have 2 plus 4. Is that equal to 7? Well, no, obviously it's not, because 2 plus 4 is equal to 6. 6 is not equal to 7. So what does this mean, what we've said here? Well, what we do, see, we found the value that made this equation true, and when we go through the steps to find the value for the variable that lets us arrive at a true equation, that's what we call solving the equation. And solving equations is fundamental to every math class you're going to take from here on out. And in order to be able to solve these equations effectively, there are 4 properties of equality. These are on the next page, I believe it's 116, that you're going to have to understand. And these sound nasty because they've got some long words. You know, it's the addition property of equality, the subtraction property of equality, the multiplication property of equality, and the division property of equality. And this is nothing to be afraid of. It's just, these are just operations we can perform that are legitimate and acceptable and will help us when we are solving equations, and these are called properties of equality. You must know these. So first we have the addition, I don't know what order they're in your book. The addition property of equality, and what that says is if you have a balanced equation here, or a seesaw, it says that if you add the same quantity to both sides of the equation, then you still have an equation that remains in balance. And this addition property of equality, you're going to use this to solve equations that contain subtraction. Like this one. The example that they give you is x minus 29 is equal to a negative 58. We've spent time talking about inverse operations. We have addition and subtraction, multiplication and division. We're going to use this addition property of equality here to solve x minus 29, because what we're going to want to do is add 29 to both sides of the equation. And an example of how this might work just with arithmetic is, let's say that you start off with 5 is equal to 3 plus 2. And everyone here would agree with that. What if we said 5 plus 4 is equal to 3 plus 2. Okay, here we have 5 is equal to 5. Now we have 5 plus 4, which is 9, is equal to 5. Obviously not. What are we going to have to do to make this equal 9? Yeah, you have to add a 4 to that side of the equation as well. And this is what we're talking about with the addition property of equality. You add the same quantity to both sides of the equation, and your equation is in balance, and it doesn't change the values involved. And they have some very specific general math formula that they use here. This is what you need to recognize. It says, and this is the addition property of equality. If A is equal to B and C is a real number, then A plus C is equal, let me make sure, then A plus C is equal to B plus C. They're just saying, here we've got three numbers. Let's say that we start with a statement here that says A is equal to B. Something is, whatever these values are, they're the same. Well, if you go ahead and add another unknown number, we'll just call him C. If you add him to both sides of the equation, your equation remains in balance. And this is what they call the addition property of equality. Now, the subtraction, multiplication, and division properties of equality are all the same general idea. Let's look at those a little bit more briefly than we looked at the addition property of equality. So we have, well, the first one was addition. The second one is the subtraction property of equality. And if we're talking about inverse operations, we know subtraction is the inverse operation of addition. So we're going to use them to solve equations that look like this. X plus 7 is equal to 21. We've added here, that zips our jacket up. If we subtract 7, unzips our jacket, gets us back 2x all by itself. So we are going to solve this problem by subtracting a 7. And again, we have to do that subtraction from both sides of the equal sign in order to make that stay in balance. So then you have x is equal to 14, and yes, 14 plus 7 is equal to 21. And just like they did for addition, they have a general algebraic way of describing this subtraction property of equality. And of course, I should not have erased this. If A, B, and C are real numbers, and if A, B, and C are real numbers, then A minus C is going to be equal to B minus C. And in my desire to make sure I got this right, I left out a piece of information. What did I leave out? If A, B, and C are real numbers, and if A is equal to B. If we have it set up so that our two values on either side of this equation, on either side of this equal sign, if they're equal, then we can go ahead and subtract C from both sides of the equation without changing the value, and that equation is still going to remain in balance. So that's what they call the subtraction property of equality. Now, what shall we do next? Well, how about if we do the multiplication property of equality? And I bet you know exactly what we're going to be using. Multiplication is the inverse of division. So you're going to use it in problems that look like this. X over 4 is equal to 23. This says x divided by 4. Well, multiplication, as I just said, is the inverse of division. So I'm going to multiply both sides of this equation by 4, and I'm going to come up with the fact that 92 is the value that we have for x, because 23 times 4 is 92. So this is the multiplication property of equality. What are we going to have to change down here? If A, B, and C are real numbers, and if A is equal to B, then we're going to want to multiply both sides, aren't we? By the same value, which is what we're going to use right here, where we're multiplying both sides of this equation by C. So it looks different now, but it has the same value to it. Finally, we have the division property of equality. Division is the inverse of multiplication. So that's when we're going to use it, isn't it? We have the division property of equality, and it's going to be when we have something that looks like this. 4 times x is equal to 16, and we want to know what the value is for x here. Now obviously it's going to be 4, because 4 times 4 is 16, but let's pretend we didn't know that. Which property of equality are we going to use? We're going to use the division property, because division is the inverse of multiplication. And we've multiplied here. We've multiplied x by 4, so now we're going to divide x by 4, and to keep our equation in balance, we have to divide this 16 by 4 as well, and that's how we end up with x being equal to 4. So that's our division property of equality, and it's almost exactly the same as the other 3 statements, but it's got a little twist. if A, B, and C are real numbers, and C cannot be equal to 0. Let's see if that's how they're doing this. Are real numbers, C is not equal to 0. In other words, C has to be different from 0. Not equal to 0. Real numbers again, except one of them, the C, cannot be a 0. And if A is equal to B, then you divide both sides of that equation by C, and you have another true equation. Divided both sides of this equation by C, and you now see why we have to put that little qualifier in there that says C can't be equal to 0, because you're not allowed to divide by 0. So, this is the fourth property of equality that you're going to be working with. Still getting a ton of vocabulary, aren't you? There's just a lot of vocabulary in math. So let's go ahead and look at some of these right quickly. You guys have the odd exercises assigned, so let's see what we can do for a moment. In each problem below, the left side of the equation has been changed. What must you do to the right side of the equation to maintain balance? We have 2, 4, 6, 8, and 10. We had originally x plus 7 is equal to 15. Then your book will say x plus 7 minus 7 is equal to what? We're using our subtraction property of equality. We're going to subtract the same quantity from both sides of the equation. So we're going to have 15 minus 7. What you have to do is you have to subtract 15. That's the answer that they're looking for. They simply want to know, what do you have to do? Don't have to write this at all. I wrote this here to illustrate what we're doing. Okay, let's go ahead and look at problem number 4. X minus 3 is equal to 24. X minus 3 plus 3 is equal to, what are we going to have to do to this right-hand side of the equation? Well, we added 3 there. We're going to have to add 3. This is all they want you to do. Problem number 6. 24, I'm sorry, that's number 7. 24 is 8 plus 4 is equal to 12. They manipulated it so we have 3 times the quantity, 8 plus 4. What are we going to have to do to the right-hand side of this equation? Well, we've multiplied the left by 3, so we're going to have to multiply by 3. All right, let's look at number 8. Number 8 says 20 is equal to 4 times x. Well, you heard what I just said. 4 times x. It's multiplied, so, well, I guess I should at least show you what they wrote down instead of solving the problem. And they had 20 divided by 4 is equal to. What are we going to have to do? You're going to have to divide the right-hand side of that equation by 4. Our division property allows us to do that. Division is the inverse of multiplication. So we're going to divide by 4. Okay? Let's see, label each equation true or false. That's problems 11 through 18. And the way that you're going to know if those equations are true and false, you're going to have to come up with the simplified form of the phrase on either side of the equations. So, that's what you're going to be working with on section 3.8. It's really pretty straightforward. But as always, if you get stuck, send me a text or ask me a question in class on Friday. Thanks, and I'll see you next time.